Today we're going to be talking about assignment 4, and before I get into that I wanted to explain just a little bit about the schedule remaining for the rest of the course. So assignment 4 is the last official assignment, and so today assignment 3 is due and the project proposal is also due, so by the time you're watching this hopefully you've submitted that project proposal. And as I just talked about, the project proposal, as long as you have covered most of the points that are in the project specification in the proposal, you'll get full marks on that. It's more of a milestone than something that I'm going to spend a bunch of time really harshly marking, because it's about getting the groups together on time and getting an idea formed far in advance of actually having to submit the thing. So assignment 4, we've covered everything that we need to know to complete assignment 4, and all of the remaining lectures are stuff that you're going to need for the project. And so as we go forward, all these things like shaders, maybe advanced game loops, code profiling, dragging and dropping, particle system stuff, all that stuff is for the project. And because we sort of eliminated one of the lectures at the beginning of this class, I'm going to make another lecture. So there's a blank spot here. All of these things now can be reordered. So they may be reordered. So just keep in mind that this can change. And I'm going to fill this with another interesting lecture. I have a couple of different ideas. I'm not sure which one I'm going to pick yet, but hopefully that will be interesting. So just to let you know, yes, the rest of the stuff in the course is necessary, just not for the assignments. It will be necessary for the project. So I do have the README file that I will be going through, just like every other assignment. But just like all of those, I'm also going to be doing the demo of the assignment first. So let's do that. So here we'll run the assignment, and we see it is definitely not Zelda. So just to let you know, first, this is a Legend of Zelda clone from the NES, just like the last one. There are sounds in this game, so you'll probably be hearing sounds on the video. It's kind of difficult to hear them here, but like if you just, I don't want to turn it up too much on my laptop because if I do, it will be very loud on the video. But like there's a sound when you pick up an item, there's a sound when you die, there's a sound when you get hit, there's a sound when you attack with the sword, etc. There's also supposed to be music playing, but if I had music playing right now for the whole hour of the lecture, it would be super annoying. But there's like menu music, there's in-game music. We'll talk about that in the README file. And over here in the debug menu is actually all the sounds in the game. So you can actually play that music. You can hear a bit of the Zelda music there, but I'll stop that. So the debug menu can actually play all those sounds as well. So that's why you're not hearing the music, because it would be super annoying if I had to do that. So the first thing that I'll go over with this assignment, of course, you can see some of the things that are new. I also, in my version of the assignment for the solution, I made the IMGUI window a bit smaller because I've added something that I'll go into a bit, and it was just a bit too big when I tried to double size it like I have for all the other assignments. But the first thing that's really different about this assignment is now we've got this sort of top-down game rather than the platformer that we made for assignment 3. And this is broken up into different rooms. So you can see here, as Link is, or not Link, I guess, for copyright reasons, is moving around, the camera is not moving. So I am within this, what I'm calling, for purposes of this assignment, a room. And so this is one room. And as I leave that room to go to another room, I'm in another room. And so, oh, this guy is chasing me. This is going to be a theme as I'm demoing this. There's going to be NPCs with behaviors, and I'll get into that in a bit. Then I come over here, and I'm in another room. Then I go up here, and I'm in another room. And then I go over here, and I'm in another room. So I've basically made 5 rooms for this assignment, and then you walk around within this assignment. Just like assignment 3, there will be a grid that we are building our levels on. So if you click Draw Grid, here it is. Just to make it a little bit confusing in comparison to assignment 3. So we're going back to 0, 0 being in the top left for the grid in this assignment. The reason we had it in the bottom left for assignment 3 is because there was like up and gravity, so it was just a little bit more convenient if we expressed it that way. But in this assignment, 0, 0 is in the top left. And so we have now two sets of coordinates for this assignment. One is the room coordinate. So the default room is room 0, 0. If I go up, well, that's -1 in the y. So this is room 0, -1. If I had gone to the right, that would be room 1, 0. And then within the room, there are grid coordinates. So I'll get into that a little bit more when we talk about the level file, etc. But we do have now two coordinates, one for the room and one for the grid cell within the room. So hopefully that makes a bit of sense. Over here, we can also toggle debugging the textures, of course. There's also some debug information here. You can see here that some of the things are white, some of the things are blue, some are red, some are black, and I'll talk about what those are in a bit, but there's lots of debug information. There's also some lines coming out of Link, and they go towards NPCs. We'll talk about all that. There's also this follow camera. So there is this standard view that we have of Link walking around in the rooms, but we also have this follow camera that we can enable. Okay, so that just centers Link in the center of the screen, and we talked about all those different views in one of the previous lectures, cameras and views lecture, and so that's what this is doing. So based on whether or not that is enabled, you'll have to change the way that the camera view is set up in SFML. So let's just go back to there. As I mentioned before, there are now sounds in this game, so the assets class can now load and play sounds, and I'll talk about that a bit more when I get into that part of the README file. One of the bigger differences is that there are now NPCs in the game with different behaviors. So let me just restart this real quick, and I will minimize this so you can see. So right here we have two different types of NPCs. Right here, I forget the name of these NPCs. There's like Tektites, and then, what's the name of the knight? Oh, I can't remember what Zelda calls them. But anyway, there's this knight guy over here, and then there's these Tektite guys just hopping around down here, and they both have animations, so you can see that the knight is kind of doing this, and the Tektites are like jumping up and down. And there's two different behaviors that we're going to define. One is called the patrol behavior, and the patrol behavior down here, you can see that these two NPCs are just sort of following a path. And if I turn on the debug information, you're going to see the information of that path. So for example, this guy down here is just going back and forth between what I'm calling these waypoints, and this one has 4 different waypoints and is going around in a cycle. So in the level file, we'll be defining the behavior of NPCs based on these behaviors, and we'll be defining all those waypoints, etc. And then in the AI system, which is a new system that we have in our game, you're going to be actually implementing the behavior for that. The second type of behavior that we have is going to be called the follow behavior. And this knight over here has a follow behavior. And because of that, I've drawn this debug line between Link and the knight. And what that line is, that is the line of sight between them. So from the center of Link to the center of this NPC, you can picture that as where maybe their eyes are, right? So I'm not actually going based on the animation, just based on the center. And over here, we have this tree, and this tree we have set up with a Boolean that says this tree blocks vision. And so right now, this line, if that intersects with the bounding box of this tree, then the vision is blocked. But if the vision is not blocked, then this NPC will follow Link. So if I move up here so that the vision is not blocked, then this NPC starts to follow me. But at any point, if the vision is blocked, then that NPC will try and go back to their home, okay? You see he's getting a bit stuck there because there's no actual pathfinding in the game. It's just trying to move directly toward that place where it came from. But again, if there is no vision blocking, then it will move toward me. I'll go over here to show you one more thing, which is kind of interesting. So I've set up over here 3 patrolling NPCs and 1 following NPC, and I've set it up so that these NPCs actually block vision. And so you can see that this NPC is trying to get to me, but every time one of these NPCs moves in the way, the vision is blocked, right? So we'll be doing all of this, and you can think of all the cool things you could do with the project with something like this, where you have different behaviors based on whether or not you can see something. And this is going to use all the math from that line intersection and raycasting lecture, the video that I released on the spreadsheet. As well, we now have hit points and damage. So let me just reset this real quick. So it may be hard to see here, but over the top of Link and all the NPCs, you have this health bar with little lines indicating how much health you have. So if I go down here and touch this NPC, I'll take some damage. And so now you can see that, okay, Link has 3 hit points and only has, well, 3 hit points maximum and 2 hit points remaining. Also, when I get damaged, because damage is going to happen when we collide, and we're checking those collisions on every frame, right? So if I check the damage every frame and I overlapped that NPC for 3 frames, I would basically like instantly die, right? And so what we do is I'm going to set up some invincibility frames. I can't remember for exactly how long, maybe a second or a half second or something. But when I touch this NPC, you'll see that Link is going to become transparent for a little bit, and that's called invincibility frames or iframes if you've heard that term before. And what that does is that if you detect a collision while Link is invincible for these few frames, then he won't take damage, right? So that'll prevent you from instantly dying if you touch an enemy. So that's what happened there. We also have a heart. If I collect a heart, then I go back to full health. So that's just some cool things to help you get started with the project for different items. And of course, the NPCs have hit points as well, and also a damage component. So now that we have health, we should have damage. We're no longer just dying in 1 hit. So you saw that when I attacked that NPC, it took 1 damage, and that's because my sword has a damage component set to 1 damage. When I touched this NPC, I took 1 damage. That's because that NPC had a damage component of 1. But if I touch this knight, I'll take 2 damage because that particular NPC has a damage component of 2. Right? So that's how we're going to set it. We'll have a damage component, we'll have a health component. Whenever there's a collision between 2 things that should take damage, then one will do its damage component worth of damage to the health of another thing. And of course, if I get hit again, I play a sound and then I respawn back to the middle. I have built in, so I've also built in some cool stuff. If I come down here, for example, this guy's going to chase me, and I turn on the debugging, and I turn off the textures, you can see that, okay, oh, geez. Hang on, I got to kill this guy. So down here, there's some things that are black, some things that are red. What is this? Okay, I'm getting attacked from all sides. So some of these are black, and what I've done is I've just colored the tiles based on whether they block movement, they block vision, or they block both, or they block none. So black means that they block movement and vision. Red means it blocks vision, but not movement. And I think white means it blocks neither. And blue, there is a blue somewhere, blocks movement, but not vision. Okay? So down here, what I've been able to do is if I turn this on, this just looks like, you know, oh, how would I get in here, etc. But what you can do is if you turn on the debug, this is sort of the cheat code, you can see that this one is red, so I could actually move in here, right? So this is a way to set up kind of secrets in your game. And if I didn't have the debug information on, oh no, I can't get into this tree, well, I can, and I can move over that one. Another thing in the game is these black tiles. These are teleportation tiles. And when I go onto one, it teleports me to a random other teleportation tile in the level. Okay, so I iterate through my entities. I find which one is this black tile, and I just teleport to that. And the last type of tile is one that blocks movement but not vision. And the sort of intuition behind that would be something like a lake, right? Or water, where of course you can see over the water, but you can't move through the water, right? Now, if you wanted to be really clever, you could do something like, oh, maybe certain enemies have a property where they can swim, right? And then they could move through water or whatever, but we're not getting this complicated just for the assignment. So I think that is all the properties of the assignment itself. And of course, up in the debug here, I have things like all the different animations and the entity manager. But one other thing that I've done for the solution to give you sort of a taste for the level editor, so I don't have a complete level editor here, but what I did do was implement some mouse logic here. So if I click in the level, nothing happens. But if I click on something that isn't nothing, then what it will do, if I click on an entity within its bounding box, I'll get this sort of information. So I have in the solution this idea of a selected entity, and that will bring up this information box here. And I know that this is, sorry, it's quite small for you to see in the classroom. Hopefully you'll see it on the video. But what this does is it has all the different properties of that entity. So what I do in the solution code is I go over every type of component, and I say, if this entity has this component, then draw all the information of that component. So for example, let me take this one up here, and then I have things like, oh, here's its X position. And then I can just like move it, right? Now that's not the best way that you would want to implement a level editor, but it's certainly interesting from a debugging point of view. Like I can change the scale, I can change the velocity, I can change which way it's facing, etc. Change whether or not it blocks movement or blocks vision. So if I go back here and then enter it again, for example, if I select this one, and then I say, okay, this one no longer blocks vision, then this knight will come directly toward me. And now if I say it doesn't block movement, then this knight can move through that, right? So you can do all sorts of cool debugging stuff with a system like this. Also, if I click on the NPCs, they will have more different properties. And so, for example, down here is the animation. I could say whether or not it's repeating. I can say whether its bounding box blocks stuff. Oh yeah, it's health. So if I click on Link here, I can change the current health or the maximum health. So now Link has 10 max health and this current health. And I can change this one. Oh, how much damage does it do? It actually does like 6 damage. So I come down here and Link takes 6 damage, immediately dies. So it's cool. You can, there's lots of cool stuff that you can do with these debugging interfaces. So I just wanted to show you that. I'm not going to give you all the code for that because that's going to be a big part of making the level editor. But this is, I don't know, I find it really interesting how easy this makes debugging and level editing and stuff just by using IMGUI. Okay. So now that the demo is done, let's get into the assignment code, or the README file, and then after the README file, I'll get into the code itself. So the submission notes are basically identical to assignment 3, so I don't need to read all of those. You're just zipping up the source folder and submitting that. So project specification, assets. Entities in the game will be rendered using various textures and animations, and we also have sounds now. So the sounds are just, an extra thing in the assets file, and we can play those in the game engine. And it turns out that it's really, really easy to play those sounds, and you won't actually have to write any code for the sound loading. I've already done that for you in the assets class. And so when we get to the sounds part, I'll read that. This is the same as assignment 3. Okay, so the player entity is represented by NotLink, which has several different animations: run down, run up, run right, stand down, stand up, stand right, attack up, attack down, attack right, and you must determine which direction and state that the player is currently in and assign the correct animation. So let's go have a look at what that means. So it may not have been super obvious at first, but here Link is standing down, like just facing downwards. This is to the left, this is to the right, and this is up. Now, Link actually only has down, up, and right because left is just a mirror of right. So you don't need to have a left, but up is not a mirror of down, right? You see that's not the case in this particular assignment because Link's face is showing versus the back of his head is showing. So you can't just mirror that. Also, there is an animation while walking, which is different than the standing animation for both directions. And there is also an animation for attacking where Link sort of pokes the sword out. Link and the sword are two separate entities. And we can see that that's the case when I draw the debug, and you can see these are two separate entities with two separate bounding boxes. So I'll just leave this running. The player is assigned the following animations in the direction that they are facing. Please note that left will be accomplished by mirroring right. So stand in a direction, that's when there's no input being given to the player. Run in a direction is when movement input is being given to the player. And attack direction is when the player's sword is currently visible. So what I mean by stand dir is there'll be a stand right, stand up, stand down, attack, whatever. So those are the animations. Just standard WASD movement with attack as the spacebar for this assignment. The player can move up, down, left, and right at any time during the game. The player can only move either horizontally or vertically at any given time. So for example, if I go back to the game, well, there's two things here. One is if I'm holding left and then I press right, then Link is no longer moving. So simultaneous cardinal direction movement, you cannot do that. So if left and right are being held, similarly, if up and down are being held, there is no movement. But if I hold right and then hold up, or left and then hold down, whatever direction you want to go of those two buttons that you just pressed. So for example, if I hold up, then right. So in my assignment, I'm just choosing horizontal direction as the priority. So if I've got a diagonal held, then I'm going in the horizontal direction. But you can't move diagonally in this game. It's only up, it's only horizontal or vertical. Something I forgot to show in this little debug menu, which is kind of interesting, is that if I click on Link, I actually have access to Link's input component down here, so I can actually like click on and off the input component and issue those actions as well. So that's pretty interesting that you can debug that way as well. Oh geez. Let's see here. Where were we? The player can only attack once its current attack animation has finished, and so you cannot attack until your attack animation has finished and the previous sword has disappeared. So you can't like throw multiple swords out in front of Link. The player collides with tile entities in the level whose bounding box blocks movement, and you can't move through them. The player will be given a bounding box size specified in the level file, so that's the same as assignment 3. The player will be given a health component with a max health that is specified in the level file. And by default, when the entity is spawned, it is given its max health. So if its max health is 3, then the current health is also set to 3. When the player's current health is less than or equal to 0, the player respawns and the Link die sound should play. If the player has an invincibility component, it takes no damage from enemies and its sprite is made transparent. The duration of the component is reduced each frame, and when the duration reaches 0, the component is removed, making it vulnerable to attacks again. So that's what we did here. Let me just demo it one more time. So down here, if I get hit, you'll see that Link turns transparent, and while Link is transparent, he's not able to take damage. So the way that I've implemented that is that if you get hit, you attach a component called invincibility. That has a specific duration. And if you're checking for collisions, if Link currently has an invincibility component, then he no longer takes damage, right? And so that invincibility component, its current duration gets subtracted every frame in one of your systems. And that may be like a status system or whatever in your project. So you can think that this could also be something like a sprint potion or double damage or all these different power-ups that you could have. And then when that duration reaches 0, you simply remove that component. When the player collides with an enemy while not invincible, the player's current health is reduced by the enemy damage component, the Link hit sound should play, and the player is given an invincibility component which lasts for 30 frames, or half a second if we're playing at 60 frames per second. Other entities. Each tile and NPC in the game specifies 2 Boolean values, whether it blocks movement and whether it blocks vision. If a tile blocks movement, then the player collides with it and cannot pass through. If an entity blocks vision, then it affects the line of sight calculation, and we'll talk about that in a little bit. So that means that the bounding box component has 2 new Booleans to reflect those changes. So if we, when I go to the code, I'll show you what that is. It's just blocks movement and blocks vision, essentially. When the player steps onto a tile with the black animation, just meaning it's a pure black tile on the level, they are teleported to another random black tile on the level. So that's what I showed here, which this one here, if I click on it, this is a type tile. It has the animation type of black, and so when I walk onto that one, I go to another random one. I haven't done any duplication checking to see if I'm teleporting back to that same one, so you don't have to do that as well, as long as you're teleporting to a random one. Attacking. When the player attacks, a sword appears for 10 frames. Oh, my game crashed because I hit the Alt key. Good old Mac. Let me run that again. I keep pressing the Alt key to Alt Tab. So when the player attacks, a sword appears for 10 frames and then disappears approximately 1 tile away from the player in the direction that they are facing. So let me do this without pressing the Alt key. If you attack, the sword has to appear in the direction that you're facing. So if it's to the left, if it's up, if it's right, or if it's down, and that's approximately 1 tile away. So just like adjust it, just, you know, plus 64 pixels in either direction, but you do have to know what way Link is facing. The player's sword should be given a bounding box equal to its animation size. When the sword collides with an enemy, it deals its damage component worth of damage to the health component of the enemy that it collides with. The sword should only do damage for 1 frame, and then its damage component should be removed so that it does not deal damage for every frame that it overlaps. So that would be an issue, right? If the sword is actually visible as an entity for 10 frames, then that would mean that, okay, if it's colliding with an enemy for all 10 frames, it's going to be dealing its damage component for all 10 of those frames. But we want it to just deal its damage once. And the way that we accomplish that is really simple. When it deals damage, remove its damage component. And then for the duration of the rest of the 10 frames, however long it has left, it's not actually able to deal damage to the enemies. So this is really interesting because with these components and the removing of components, you can do interesting things for the project. One of the cool things that I saw in a previous project was like a piercing arrow, right? So let's say you have an arrow and you want it to be able to pierce through one enemy and then hit one more enemy behind it, right? So you could have a pierce component, which has a count of the number of things that it has hit, and then if it goes through one, it gets removed, and then if it goes through another, it gets destroyed, right? So using these components, it's pretty easy to do this sort of thing. When the sword is swung, the slash sound should play. When the sword collides with an enemy, the enemy hit sound should play. When an enemy's health is reduced to 0, it is destroyed. And when it's destroyed, it has that little explosion animation that plays. And when an enemy is destroyed, the enemy die sound should play. So let me just show that once more. So down here, if I attack this enemy, when its hit points go to 0, it is destroyed. Well, it's replaced with the explosion animation, which is non-repeating, and when that finishes, then just like assignment 2 for the brick, it is destroyed. NPC Entities. So this is entirely new to assignment 4 and will also be required for the project. NPCs will be given an AI behavior in the level file, which is either a follow behavior or a patrol behavior. So follow means that it will follow the player when the player is in direct line of sight, or head back to its original position when not in line of sight. When an entity is at its home position, it should not oscillate. What that oscillating behavior means is that what you're going to have to do is you're going to have to detect when the entity is close enough to its home position. But you probably shouldn't do something like say, is it exactly equal to its home position? Why? Well, let's say, for example, it is currently 3 pixels away from its home position, but the movement speed of the entity is 5. Then what will happen? You'll move it by 5, it'll overshoot by 2, and it'll say, okay, now I'm on the other side of home. So on the next frame, you'll move it by 5 again, and now it'll be back 3 away on the other side, and it'll just be jittering back and forth, right? Oh, jeez. What's going on? Oh, one of them found me. Okay, sorry about that. So you don't want that sort of oscillating behavior. What you want is for that NPC to just stand there non-oscillating. So what I've done is I've just chosen some value, some small number, which is less than the speed of that entity. Maybe it's 5, maybe it's 8 or something. So whenever I'm within that distance of home, then I stop its behavior. It's considered at home at that point. So that will help stop the oscillation. as well as for these patrolling entities, you'll also need to do something similar so that it doesn't oscillate around those patrol points. So, okay, am I within some reasonable amount of distance of those home points? And it's probably, I don't know, 5 or 8 again. That's what I used for the patrolling behavior. Patrol means that it will move toward a series of patrol positions, looping back around to the start when the final one is reached. An NPC has reached its patrol position if it is within a distance of 5 from it. Okay, so I've already set this up. Now, if I go back to this for a second, what you can see here is that the order of the patrol positions is actually important. So I have specified the patrol positions by this one being first, then this one, then this one, then this one, and then it goes back to the start. So you're going to have this vector of patrol positions. You're going to start at the first one. When you've reached that one, you're now going to the next one, to the next one, to the next one, and when you've reached the last one, your target is just you go back to the start of that vector, and you iterate through all of that. So if I had said this one, then this one, then this one, then this one, then the NPC would be walking in this sort of zigzag pattern, right? So it does matter what direction or what order you specify those in, because that's literally the next target that it will follow. And I will, when I get to the level file spec, I'll talk about exactly how that's defined in the level file. Tiles. Tiles are entities that are defined in the level geometry. Tiles can be given any animation in the assets file. Tiles can be given a bounding box equal to the size of the animation. Oops, this is a get. And this is get. In the older version of the assignments from previous years, I had get component, and that was just too long to type, so I just changed it to get. So you have, these things are the same as assignment 3. That's how to get the size and name of an animation. And if a tile is the heart animation, any NPC that collides with it should have its health filled back to maximum, and the tile is destroyed. And so the NPCs can pick up the items in our game as well, which is kind of interesting. Not a lot of games do that. Drawing. The game window is drawn with a fixed size of 1280 by 768, not 720. So this because 720 is not a multiple of 64, and our tiles are 64 by 64. So this means that our rooms have size 20 by 12 in terms of tile coordinates. The rendering of entities is done for you, as well as a debug rendering mode, which is toggled with the F key or the R key, or you can click it in the little debug menu as well. You are required to change the camera position, which is the Windows view, of the game window to alternate between modes based on the mFollow variable. So if mFollow is true, then this is the follow mode camera, which means that the camera is always centered on Link. And if it's false, it means it's the room mode, so the camera is centered on the middle of the room that Link is currently in. And so for that, what you have to do is figure out, okay, which room is Link in, and then center the camera on the center of that room. Shouldn't be overly difficult to do that. What is a room? Each level is split up into individual rooms and given an Rx, Ry coordinate. So that is room X and room Y. So room Rx, Ry is defined by the rectangle Rx times W, Ry times height, where width and height are the window width and the window height. Okay, so if you think about it, room 0, 0 just starts with 0, 0 up in the left-hand corner, and width height down in the bottom. So let's just bring it up. Let's turn on the debug. So this is room 0, 0. So that means this coordinate is 0, 0 in the world, and this coordinate is width height in the world. If I go over here, then this is room -1, 0, because we've gone -1 in the x direction in terms of room coordinates. So this coordinate in world coordinates would be -1 times width times the width of the screen, and down here we would have -1 plus the width, so this would actually be 0 down here, right? So that's how you would translate between world coordinates and room coordinates. Each tile is given a TX, so a tile X and a tile Y grid position within a room. by default, grid size, the grid cells and tiles all have size 64 by 64 pixels. And when NotLink moves to a new room, the camera should center to that room if the follow camera is not currently active. So I've got some miscellaneous stuff here. These are just the controls of the game. That's very similar to assignment 3. But we have this Y key. That is the camera changing key. So if you don't want to go up here and hit the debug thing, then you can hit the Y key to change that. Okay, so those are the mechanics of the game. Relatively simple mechanics, but again, it does take some effort to actually implement all that stuff. The assets file specification is identical to assignment 3, but now we have sounds. Okay, so if I go over to the assets file, which is in the bin directory, I have some sounds here. So if I go into the assets file, at the very bottom, I've defined some sounds like this. So it just says sound, and then the name of the sound, and then the wave file or the OGG file, which are the two sound types that SFML supports. So that's the only changes to the assets file. So I don't need to go into any great detail there. But the level file is different. It's similar, but different. So I do want to go over this. So inside the level file, we have the player specification. So let me just go open one of the level files here. Okay, so I've got this, and I'll go to the bottom for the player. So down here, I've got the player specification, and there are fewer configuration options for the player in this assignment than there were in assignment 3, but let's just see what they are. So we've got XY, that is the spawn position of the player in XY coordinates. So that is actually given in world coordinates, not in tile coordinates. So just spawn the player at that location. Then we've got the bounding box size. So that's BX, BY. So that is 48, 48 in this case. And then we've got a speed. That is the speed that the player will move when they're moving around. So that's going to be 5. And then this 3 here, that is going to represent the maximum health of the player. So if I change that to 10, then Link would spawn with 10 maximum health in the game. So that's pretty easy for the player. The tile specification now comes with the animation name first, then the room X and Y coordinate, then the tile X and Y coordinate, and then a 1 or a 0 based on whether it blocks movement and whether it blocks vision. So if I go into the level here, and let's just go up to the top. Let's see if we can find that first black tile that I was talking about. I hate how, I gotta turn this thing off, where Visual Studio, there we go, highlights all the things that I have selected. Okay, so here's the first black tile. It is in room 0, 0, and it is at grid position 4, 3, and it does not block movement, and it does not block vision. So let's have a look at that. So this tile, you can see it here. It is in room 0, 0, which is the starting room, and it is at tile position 4, 3. So similarly to assignment 3, you're going to have a function which takes in Rx, Ry, Tx, and Ty, and you have to figure out the center position of that tile based on those coordinates. But you should be able to do that pretty easily by now. So that's the tile specification. But here's where it gets a little bit tricky. That is the NPC specification. So the NPC specification starts off with NPC, and then it's given a name. Then it is given, just like the tiles, it's given a starting position, which is in room and tile coordinates. So Rx, Ry, Tx, Ty. Then whether this NPC blocks movement or blocks vision. So that's so far identical to the tile specification. But now it's got a maximum health that shows up and a damage, and then it's got an AI string. So if you see the string AI, it means that this is an NPC that has a behavior, and then the next thing in that line will either be follow or patrol. If it is follow, then the only thing that's specified after that is this S. Okay, so let's try and look for that knight in the file. Where is the knight? Where are you, Mr. Knight? Did I put you down? Okay, so here is the knight, and it says NPC knight. It spawns in room 0, 0 at tile position 16, 6. It doesn't block movement. It doesn't block vision. It has 5 health. it does 2 damage, it has a follow behavior, and the speed that it follows you is 1. So whenever it calculates, I want to move toward the player, right? You know how to do that now. You've got to normalize that to 1, and it's just going to, well, in this case it's 1, but you normalize it and multiply it by the speed, which is 1 in this case. So if you made that faster, then it would just be moving faster towards you. The more complicated one is the patrol behavior. And so this is going to have a variable number of input arguments on this line. So it may be a little tricky at first to figure this out. So if after AI comes patrol, then you're going to have first a patrol speed, then a number of patrol positions. So this number might be 3, for example. And then the positions 1 to n after that n are going to be xi and yi, which are the tile positions in that room of the patrol positions. Now that sounds a little complicated, but it's actually pretty easy. So for example here, this is that first patrolling tektite. So this tektite down here, let me just reset things. This one is moving back and forth between 2 patrol positions. Okay, so how do we specify that one? Well, this first one is going to have a patrol speed of 2, so it's moving back and forth at the speed of 2. It's going to have 2 patrol positions, so that means there are going to be 2 times 2 numbers remaining. And the reason it's 2 times 2 is because each of the 2 positions has an x and a y coordinate. So it is going to patrol between the positions 3, 9 in tile coordinates and 7, 9. So if we go back and we turn on the grid and we look, okay, position 3, 9, that's where one of the patrol positions are, and 7, 9, that's where the other patrol position is. If we look at this guy over here, he's got 4 patrol positions at what looks like 15, 7, 17, 7, 17, 10, and 15, 10. So let's see if the level file matches that. So it says patrol at a speed of 2. You're going to have 4 positions at 15, 10, 15, 7, 17, 7, and 17, 10. Okay? So in the component system over here, if I go to the source code, where is the source? In the components, you've got 2 new components. One of them is follow player. So the follow player component is going to record where the home position is and the speed. Okay? And the patrol component is going to have 2 things, which is a vector of vec2fs. Those are the positions of the patrol points. And then the second thing is, which patrol point am I currently heading towards? So what's going to happen here is that you've got, okay, let's say I've got 4 patrol positions. Then initially, I'm heading towards index 0 of those patrol positions. So I'm heading toward the first thing in the vector. Once I reach within 5 distance of that first patrol point, then I increase this current position index, and now I'm heading towards index number 1, which is the second patrol point, and when I get to the end, I just loop back around to the beginning. So that's what this does. And so this takes in a constructor, which is a vector of patrol points and sets these up, etc., and it also takes in the speed. Okay? So it's conceptually pretty simple. It's just a list of patrol points, but implementing it, you might have it's going to take a little while to implement that. All right, and now I've got an example spelled out for you so that when you're looking at this, you can have this, but this is the exact example that I just said. So this means it says spawn an NPC with the animation tektite in room 00 with tile position 1510. The NPC has a max health of 2 and a damage of 1. It does not block movement or vision. It has patrol AI with a speed of 2 and 4 positions, each in room 00, and these are the positions. Okay, so that's a pretty easy spec for that. All right, so I'll get to this in a second after I go over the code. Any questions about any of that so far? Yep.
The tile coordinates for like creating a location.
Yep.
Is that global tile coordinates or relative to the room?
Relative. So that's a good question. So the question was, are the tile coordinates global or relative to the room? So if they were global, we wouldn't need a room, right? So they're relative to that room. So 0, 0 for a tile coordinate would mean the top left tile of the given row. Yeah, good question. Yep. So yeah, let's go into the code now. And I want to show you first what you are given when I give you the assignment. So I just have to remake this real quick. So let's shut this down. Go back here, make clean. Oh, one thing that I changed for Mac and Linux users is that, remember how with the other assignments, when you would type make and it would build the solution, all the object files and stuff would go into the source directory. Now I've changed the make file so that there's actually a build directory that all those files go into. So if I type make here, or make run, then this is going to build what I give you. And so if I look at that, it's not much, right? You can't move around, you can't do anything. There's just some sample code in there. And so if I go back now and look at the structure, if I look into the source directory, there are no object files or dependency files in the source directory itself. There is actually this build directory where all of those files now go. Okay? So then typing make clean to remove all those files is as simple as just deleting that directory. So it's just a little bit cleaner. That's all. So I finally figured out the syntax to do that. And so all that is there if you want to look in the Makefile to do that. Okay, so let's look at the code. Let's close some of this stuff. Actually, don't close that. Let's close the level file. We'll close components for now. And I'll just go through all of these. So the first thing I want to look at is the action class, because I did make a change to the action class. The change that I made to the action class, why is action including entity? I don't know why that is there, but I'll remove that. So a change I made to the action class is that, remember how I clicked to select an entity? Well, in order to click to select an entity, I've got to allow mouse commands into my action somehow, right? So what I've done is now I've included this vec2i. So vec2i, okay, let's go look at the vec2.hpp. Remember how we've been using vec2f, which is a vec2 of floats? Well, I've also just defined this vec2i, which is a vec2 of ints, because whenever you click with the mouse, the pixel position of the click is always going to be an integer. Okay, so that's why I have a vec2i now. And if I go over here to the GameEngine, the only change to the GameEngine class is down here in the user input system, where I now have mouse actions as well. So the reason I did this is because when it came time for the project, some people were having trouble last year with how to create actions for mouse events. So I've just done that for you here. There's no actual controls of the game that use the mouse, but I wanted to have this code here for you so that you could do that for the project. So what we do is we say, okay, there's two steps to this. I'm going to detect that a mouse button was pressed. And if so, then I'm going to issue an action with the button. So if it was a left click or a middle click or a right click, now I've got an action, which is starting of a left click, which means holding the button down. And then down here, when I've got mouse button released, now I have the ending of a left click. There's a panda dying in the next room, apparently. Okay, and the second thing is, which is not obvious right away, but is very important, is that where we click on the screen is not necessarily where we're clicking in the world, right? So there's a screen click position, and there's also, okay, I want to know where on the screen does that click correspond to in my actual game world. So what you could do is you could say, okay, I clicked here on the screen, and then my game world view has changed by a certain amount, so I could subtract and do all that. But luckily, there's actually a function that does that for you. And I want to go into the solution code real quick. Try not to show off too much here. Let's go into the scene Zelda. And I'm going to click, what is this, world? Yeah, okay. So there's this function, world pause. So if I get the action position, which is where I clicked in the window, there's a function on the game window called map pixel to coords. So if I have a click in my game window, I pass that into map pixel to coords, and this will return for me the SF vector2f of where in the world that clicked based on my view. Okay, so that's done for you. So if you're doing crazy things like rotations, it just figures all that out for you. So I just wanted to show you that part. That's how I'm doing it. So in my code here, the way I select an entity is I say, okay, if I've left clicked, clear the selected entity. So there is no selected entity whenever I initially click. Then I'm going to iterate through all of my entities, and I'm going to have this isInside function in my physics class, which takes a position and an entity, and then checks to see whether or not the position is inside the bounding box of that entity. If it is, then I set the selected entity to that entity. That's it. So that's how I'm selecting entities in my game. Okay, so that's enough of the solution code. Let's go back to the non-solution code. But I just wanted to explain first what's happening there inside the game engine code. I have changed this. Oh, and the one other thing that's really important is this function right here. So what this does is it tells you whether or not your mouse is currently hovering over IMGUI. So if it's currently hovering over a UI element and you click, you don't want this to be an action in your game, right? Because you want that to be an actual UI click. And so this is just the IMGUI function that allows you to filter out clicks of the GUI from being actions in the actual game. Okay, so that's enough of the game engine. Let's go back to action. So that's why action has changed. You don't have to implement any part of that for the assignment, but if you do, hey, it might help you debug, and it's also some stuff that can go towards the level editor for your project, right? So that's the change to action, and the only other change is that now there's a function that returns the position from the action. Okay, so let's see what's next. We have animation has not changed, and it is actually implemented for you. So all the things that you did to the animation class for assignment 3, you do not have to do because that's done for you in this assignment. But because that's solution code, I'm not going to click it here, right? Hopefully you've all done the animation class by now for assignment 3, but I'm just not going to click it. Assets has changed because there are now sounds. So there are two things here. One is called a sound buffer, and one is the actual sound. So let's have a look at how we load sounds. So when we add a sound, what we do is, okay, we have the sound buffer map and the sound map. And the sound itself is constructed on the sound buffer. So I don't want to get into the details of this, but the sound buffer is like the actual data of the sound. And then there's an SFML sound object, which doesn't contain the data, but points to the sound buffer. And then when you play the sound, that's the thing that's actually being getting played. And I have set the volume here to 25 because it is mind-blowingly loud at 100 and the default. So I've just set that down. So whenever you want to play a sound in the game, you just call get sound and then you dot play. So it's just get sound, assets, get sound, name of the sound, dot play, and it plays it. And remember that I said before, when it comes to sounds in SFML, you actually have to make sure that the sound object exists for the duration of the playing of the sound. So if you just set up like a main function using SFML, and then you say SF sound, here's the sound file, and then you call dot play, it won't play the sound and then exit. It'll just start playing the sound and then immediately exit the function, and your sound won't actually keep playing. And so by storing the sounds and the sound buffers in the assets class, which lives for the duration of the program, then you can play these sounds and they will play to their duration. One thing I want to show you is that if I build the solution again, go back. I got to clean this because it's completely different. So one of the side effects of this is that the current way that we have it set up, if I spam click on playing a sound, let's say get item, it doesn't produce multiple copies of that sound at once. It actually restarts the playing of the same sound. Actually, maybe the music is a better example. So it's not, there aren't 5 copies of the music playing right now. It just restarts it and then stops. So if you, in your project, want to be able to play multiple copies of a given sound, then you will have to create multiple copies of that sound object and play them and then delete them once they're finished playing. So this is the very most basic way of implementing sounds. But again, if you do want multiple copies of the same sound, then you'll have to make changes to the way that the assets are stored. All right. So that is the assets. That is all done for you. Next, we have components. Components, we saw patrol, follow player. We have state here, so you can use state to say, okay, which way am I facing, etc. Apparently we still have a gravity component, but that's not being used. Oops. We have an animation component. Bounding box has these 2 new booleans here, which is blocking vision and movement. I am lazy and left in the can jump. I'll probably remove that tonight before I release the assignment. We have health. We have invincibility. We have damage, lifespan, transform, etc. So, inside transform, I now have a vec2f here, which is called facing. And that's how you can store which direction that you're facing. So if you're moving down, which you are at the start, then down would be 0, 1. If you're facing to the left, you can store -1, 0. So facing inside the transform is how I implemented that. And that's it for components. Everything else is the same as assignment 3. Let's see here. Entity manager and entity are identical. Nothing has changed. I've already showed you what has changed from GameEngine. Inside physics, based on the lecture about line segment intersections, which you have to do for this assignment, you have, so I'm not sure, just copy and paste your get overlap code from assignment 3. That'll be fine here. Then you have a function isInside. So isInside takes a position, which is a point, and an entity, and then it determines whether or not a position is within that rectangle. Okay, so we did that in the slides. Then we have a line intersect function, and these variables A, B, C, and D, AB is one line segment, and CD is another line segment. And then what you have to do is you have to return this intersect object, which says whether or not there was an intersection and then where the intersection was. And all that is in all the code for that is in that lecture. So that's what line intersect is. And there's also an entity intersect function. And what the entity intersect function is, this is how you'll do your line of sight calculations. So vec2f A and B, that defines a line segment between point A and point B. So in your code, point A is going to be one of the entities. So for example, if I want to know whether or not a given tile is blocking the vision between myself, the player, and an entity, then point A will be, if I come over here and turn on debugging, point A will be the player, point B will be the NPC, right? And then I want to know, does that intersect with this entity? So what I have to do inside this function is take the bounding box of a given entity. So let's go in here, and hopefully this works for the video. I want to kill this guy so that he's not, go back. Okay, perfect. So now, hopefully this works for the video. I'm gonna zoom in. All right. So what you have to do for that entity intersect, whoa, geez, that scared, that legitimately scared me. All right. So what you have to do is let me just scroll. I guess he's going to be in the thing no matter what. You have to form 4 different line segments based on the bounding box of this entity. So you have line segment 1, maybe the top, 2, which is the bottom, 3, which is this one, 4, which is this one. So you have to figure out those 4 corners, form 4 line segments, and then make 4 calls to the line segment intersect function. And if this line segment between A and B intersects with any of those line segments, then it does intersect with that entity. So that is that intersect entity function. You have to take AB and then form 4 more line segments from the entity based on its bounding box, and then figure out whether or not it intersects with that. Okay, so that is the physics. Those aren't too bad. The code's already there for you. The menu has already been done. Scene has been done. Okay, so the only thing remaining is the actual gameplay scene, which we're going to go through now. So you've got the init function. This is going to be the same as for assignment 3, where you have to register all the actions, and then the load level is called. So load level, same as assignment 3, you have to go through the level, and this is where you're going to create all the entities, add them to the entity manager. So you've already done something like that before. And last time we had this grid to mid pixel function. I've just called that get position now. And so get position is going to take in the room X and Y and the tile X and Y, and it's going to take that and then return the vec2f game world position of the center of the entity. So you're just going to calculate the center of the entity based on what I've already passed in. Next, we have the spawn player function. Very similar to assignment 3. You are, instead of having all this hard-coded example code, you are going to create that from the specification in the level file. And over here in the header file, I have a player config struct and a player config, just like in assignment 3, that's already done for you. So you can read the player config directly into those structs. Next, there's a spawn sword function. So this is going to happen whenever the attack button is pressed. So when the attack button is pressed, you have to figure out, okay, is there currently a sword on the screen? If there is, then I don't call this. If there isn't, then I do call this, right? And so the sword should be given an appropriate lifespan, should spawn at the appropriate location given the player's facing, given a damage value of 1, and you should play the slash sound. So that's what happens when you spawn a sword. And the sword function gets passed in an entity. By default, that's just the player. So you pass in the player, but if you want to do something interesting, maybe the NPC AIs have swords. And so if you call this function on an NPC, maybe now the NPC can attack you or something, right? So the spawn sword or the shoot bullet or the whatever, the reason I pass in entities is because that's the entity who controls the sword. So if you want to implement some cool bonus stuff with the NPCs attacking, you can. The update function is the exact same as before, except now we have an AI system. We have a status system for the invincibility. And we have a camera system for the changing of the 2 views of the camera. Movement system is pretty intuitive. That's the same as assignment 3 in terms of what goes on inside there. The do action, again, that's the same as assignment 3. That's where you're reading in the different actions that you've registered and then performing the functionality based on those. This is where you implement the patrol and follow behaviors of all the NPCs. So you iterate through all of the entities in the level, and you say, hey, if this entity has this particular AI, then here's where I would implement that logic. Status, so instead of having a lifespan system, I'm now calling lifespan a status. So here is where you implement the lifespan and the invincibility, and for your project, any other statuses that you would have, that's where you implement them inside the status function. The collision system, again, is going to be somewhat complicated, but the good thing is that you can copy a ton of code from assignment 3 in here. So you've got the overlap already calculated, the previous overlap, and any of the collisions between the player and the tiles and the resolutions of those collisions. Like, I would literally start this function by taking your assignment 3 function and pasting it in here. Most of it should just work. All the code that collided with tiles and stuff in assignment 3 is going to work here, but just keep in mind that now you've got those 2 booleans, which is whether or not it blocks, one of them is whether or not it actually blocks movement. So by default, if you just copy it from assignment 3, it will be colliding with all the tiles, but you have to make sure to eliminate collisions from tiles that don't block movement. Animation, that is where you set the proper animations based on the status of Link and where he's facing. Here is where you do the camera logic. I've gotten a little bit of code there for you. So I get the current view. If the follow camera is active, then implement the follow cam. This is the easiest thing in the world. You literally just set the view's center to the player's position. Super easy. And here is where you would implement the room-based camera. So here you say, the first thing you do, take Link's position, figure out what room Link is in, and then figure out the center of that room, and then set the camera to the center of that room. Not too bad. On end, here's where you do things like stop the music, play the menu music, change the scene to the menu, etc. And the rendering has been done for you. Anything else in here? Oh, down here is the UI. I haven't specified anything that you have to do for the UI in this assignment. So if I haven't specified it, you don't have to do it. So there's a little break from that. But why not copy and paste that stuff from assignment 3 just to help you with the debugging of this assignment, right? So you can have that entity manager over on the side, or maybe there'll be a few bonus marks if you do, you click on an entity and you can see all that information. It might help you debug and also get some bonus marks and do part of the level editor for you at the same time. So if you implement this thing where you can click on an entity and it shows all that stuff, if you do that, I'll give you, 5 bonus marks or something, and then an extra 5 bonus marks for if you do anything extra on top of that. Okay, so that's it for the code. Let me go back really quick to the README file because there's some stuff at the end. I've already mentioned this about the lifetime of sound objects, so I won't read that out again. But the assignment hints, so you can use all of your collision code from assignment 3. I recommend doing the assignment in this order. So first, implement the GUI whenever you want. That's fine. Implement WASD movement for the player immediately. So I think the first thing you should do is implement the movement for the player. That way you've got the player moving up, down, left, and right. There's no gravity to worry about, so you can just do that and get it over with immediately. Then implement the load level function. And of course, as just with assignment 3, as part of the load level function, you've got to implement that get position function as well. Implement spawn player so it correctly uses the configuration options. Implement the camera, then spawn sword, then implement the player attacking and sword collisions with NPCs and the health and the damage stuff, then the animations, then I would recommend starting the NPC behaviors, the patrol and follow behaviors. Then, based on the follow behavior is going to have this line intersect and entity intersect. So entity intersect depends on line intersect, so do line intersect first and test that before you do entity intersect. Then go back and fix the follow behavior so it properly uses the vision calculations. Then do the invincibility frames, the heart pickups, and the black tile teleporting. So all of that should be in an order where everything only depends on stuff that you've already done. Oh, and really quickly, the marking scheme, which I mean every time to go over in the lecture, but I forget. Here is the detailed marking scheme. And okay, so I actually do have the GUI functionality for this, but I'm going to change that to be like 5% or something because you've already done it for assignment 3. So there's no point in giving 5 marks. But what I will put in here is I'll fix this to list the proper bonus marks that you'll get for doing the selected entity and other stuff.